God does not play dice. This iconic phrase by Einstein was his response to the emerging quantum physics, which challenged the certainty of classical science. But what if God does roll the dice? In this video, we explore the idea of randomness, not just in physics, but also in philosophy, mathematics, biology, and information theory. The 20th century radically changed how we see the universe. Maybe the universe is not a perfectly ordered machine. Maybe it's an algorithmic storm, a system where chaos and order dance together. And maybe randomness is not the absence of logic, but a deeper language we haven't yet learned to read. In philosophy and science, randomness is not simply what happens without our control. It's a conceptual problem that questions knowledge, causality, and even the nature of being. Let's explore the English words we use for it: chance, random, accident, hazard. Chance comes from Latin cadere, meaning to fall. It evokes the image of dice falling onto a table, uncertain, unpredictable. Accident also comes from accidere, to happen unexpectedly. It implies lack of intention or design. Hazard comes from Arabic al-zar, meaning dice. It carries a sense of danger, unpredictability, risk. Random traces back to the old Germanic root rant, meaning to run, something moving fast without direction, without a defined goal. All of these words share a common DNA: uncertainty, lack of structure, absence of purpose, no predictable pattern. In philosophical terms, an event is random when it lacks four things: purpose, teleological absence; causal explanation, structural coherence; knowability. This raises a deep question: is something truly random, or do we simply not see the hidden structure? The Greeks had names for randomness and necessity. Tyche was the goddess of chance. Ananke was the goddess of necessity. In myth, the world is shaped by both: unpredictable divine rivalries and inevitable destinies. Heraclitus famously said, "The most beautiful cosmos is like a heap of random straw." For Plato, randomness belonged to the human world. The world of perfect forms, the world of ideas, was beyond randomness. Aristotle saw chance not as a primary cause, but as a coincidence, something that happens without purpose, but within the natural world. In short, for the ancients, randomness was real, but it was always balanced by order. A dice roll followed by rules of movement. Randomness was the shadow of order, not its opposite. The 20th century broke the illusion of perfect determinism. Thermodynamics taught us that energy disperses probabilistically, entropy increases. Quantum mechanics shattered Newtonian certainty. At the subatomic level, outcomes are not determined, only probable. Heisenberg's uncertainty principle tells us we can't know a particle's position and momentum at the same time. It's not just a lack of information, it's a law of nature. Einstein was troubled. God does not play dice, he said, but experiments showed otherwise. Reality is probabilistic. In biology, randomness appears through mutation, changes in DNA that are not directed or designed. Evolution by natural selection combines random variation with structured adaptation. Again, randomness and order coexist. One generates possibilities, the other filters them. Mathematics deals with randomness in many forms: random numbers, probability distributions, chaos theory, fractals. But here's the paradox. Even in randomness, patterns emerge. Fractals, like the Mandelbrot set, look chaotic at first, but they reveal infinite self-similarity under zoom. These structures are built on simple rules, repeated endlessly. In computing, random numbers are generated by deterministic algorithms. They're called pseudo-random.
That means they look random, but they're not. They're mathematically predictable. So is anything truly random? Or is our randomness just insufficient knowledge of the algorithm? What if the entire universe is just one giant computation? Some scientists, like Stephen Wolfram, argue that the cosmos is built from simple rules, just like cellular automata. Tiny rules, when repeated, produce complex and beautiful structures. Maybe reality is the output of a cosmic algorithm. Matter is information, energy is calculation, and we, humans, are part of the program. In such a view, randomness becomes apparent unpredictability, but everything is predefined by code. Then we must ask, are we free or are we variables in a simulation? These questions lead us back to the most ancient one. What is reality? Science has dismantled many classical metaphysical foundations. The universe is no longer seen as stable, continuous, or necessary. It is probabilistic. It is uncertain. It is, in many ways, meaningless. But this invites a new kind of thinking, a computational metaphysics, one where logic and chaos coexist, order and randomness feed each other. Reality is not designed but calculated. In this model, randomness is no longer an error. It is a feature, a necessary element of cosmic creativity. The universe may indeed be rolling dice, but it might also be running code. Perhaps what we call randomness is simply the edge of understanding. And maybe, just maybe, the most beautiful cosmos is a tangle of straw thrown by a mind we cannot comprehend.